Okay, hello Cisco, South Campus Cisco cohort. What is the cohort doing this week? Today I'm going to cover modules 10 through 11, covering switchport security. Before I cover those two PowerPoints, I'm going to do go into the student experience for the Cisco Network Academy. I'm going to show you guys how to view these videos. They got some real good videos on chapters 12 and 13, covering the Wi-Fi configuration stuff. I'll show you how to find those videos. You can get to view those things on your own time. So I'll be covering the PowerPoint, death by PowerPoint for chapter modules 10 and 11 today. And then Thursday, we're going to do a lab that's on switchport security, 11.6.2, and we'll do that in the Cisco lab at South Campus at our normal time at 9 o'clock. Okay, so let's see. And first of all, I need to show how to go and find these videos real quickly and easily. There's a cool little index function that you can sort through on the Network and Academy. So let's see. So I'm going to share content, and then I'm going to share. Oh, I have to stop sharing this first. Okay, share this window. I think it's this one. Oh, that's a little fuzzy looking. Okay, so I've logged into what the student would see when he goes to the Cisco Networking Academy, and I'm going to launch this course by clicking on the Launch Course button there. And then we're going to go through the procedure we normally would do to, oh dear, it wants me to give him a password again. Oh, okay. I thought I was going to have to put my password in again. Okay, so the way to click to get into the curriculum is a little bit more convoluted now in this new experience stuff. So instead of just going right to the curriculum, you go to the screen here where it has the word modules in blue and click on that. And then you go down to the course content. It's this one that says switching, routing, and wireless essentials course. Click on that blue or black. And then you don't have to click on yet another button here that says load, switching, wireless essentials course in a new window, and then you'll finally get it. Okay, so once you get the main window of the course, go up to the upper right-hand corner, and there's a thing with 3 lines in it. That's course index. I'm sort of wiggling around here to draw your attention to that location, and click on that. And then at the very top left-hand corner where it says course index, unclick the all and click the videos. And that will bring just bring the videos up. And if you roll down to the bottom of the screen, not far, you're going to come to chapters 12 and chapters 13, which are the ones I'm going to have you guys view the videos on your own time. View those videos. And that does a good job of covering the chapter 12 and 13 stuff. I'm going to cover chapters 10 and 11 today. Okay, so I'm going to go through that one more time just to make sure that was okay. I'm going to kill this. I'll go back to my NetAcad. So what I did was I went to my NetAcad and I clicked on Launch Course. Then I clicked on the modules. I think you can also click on the modules up here in the left-hand corner. Either one of those modules works. And then we go to the course content, switching, routing, and wireless essentials. Click that. And then the button, load that at the bottom. Then go to the upper left-hand corner of the screen, uncheck the all, and then slide over to the right a little bit, about halfway down to the right, and click the videos. And then roll down to the chapter 12 and 13, module 12 and 13 videos so that you can view on your own time. Okay, good, good. Now let's see. Stop sharing that. And I'm going to start sharing this first PowerPoint presentation. We're going to talk about switchport security today and some security topics in general. So we roll in. Okay, so you should see a big blue PowerPoint slideshow tile saying endpoint security. What are endpoints? Well, I thought when we had our networking fundamentals course, we talked about intermediate devices and end devices. So an intermediate device was like a router or a switch, that's something that connected things together and made forwarding decisions about moving data. And an endpoint was, or end device was something like a customer desktop PC, a student desktop PC, a server, a printer, something like that, something that sent and received data, but it didn't make any data management, routing or forwarding decisions on its own. Well, the new buzzword for this is endpoint. So an endpoint is what we call an end device. So in today's network, here are some types of ways that, we're not supposed to call them the bad guys. We're not supposed to call them the malicious intruders. We're not supposed to call them hackers. They're threat actors. So that doesn't sound so bad. So how do these threat actors try to get into your system? Distributed denial of service is a way where, like, some might come in with some type of virus software and take over 10,000 home internet cable users. And they don't know they've been taken over. He's just trying to steal some processing power on your machines to send spam or something. So he sends a chat command, and 10,000 home computers do a simultaneous trying to log into, say, the Amazon web server on Amazon Prime Day and try to keep them from making money. So, you know, the TCP three-way handshake, sync, ACK, they send the sync. Amazon sends back the sync ACK. The 10,000 guys never send the final ACK, and Amazon times out, waiting for 10,000 people to dial in. That's a distributed denial of service, DDoS. Data breach. You've heard about all these ransomwares. Well, they'll come in and for a couple months, they'll poke around in your system. They'll get in somehow through a social type attack, like open up this click and get the new accountant's thing, but it's really from the outsider. And they break into your system and they root around for a while because they want to find all your backups and delete them too, or encrypt them too. And then when they're ready, they encrypt all your data overnight one night, and everybody comes in the next day and all the machines are saying, you've got the ransomware and you have to pay us $10,000 to get it back. So that's data breach. And the latest thing these guys are doing is that they take over like a hospital or a government organization or something where they have strict data confidentiality and breach rules. They say, well, if you don't pay us in the 10 days, we're going to go ahead and release all this information to the public, including people's social security numbers and things, medical data, stuff like that. And these hospitals and these governments don't want this to happen, so they're kind of blackmailed into blackmailing. Okay, malware. So this is the type of thing that can cause all different types of problems. So the data breach guys came in and took over and found out all about your system, and then they launched the malware, ransomware. He gives the example of WannaCry. There's a bunch of them. Keep up this at the website bleepingcomputers.com, bleepingcomputer.com, and he's got a bunch of information on the latest malware stuff and how you can defend against it, ransomware stuff. They've released some free decryptors for some of these ransomwares. Okay, so how do we enforce security on the network? So the first method he gives here is a virtual private network. You can use it you can put this in a router, or you can actually put VPN code on your desktop PC. So what that does is encrypts the data between you and whoever you're talking to. This is similar to the method when you go to your banking website and use HTTPS. All the information over the wire is totally encrypted and nobody can get that data because they don't have the key. So virtual private networks are used by corporations. Like in this work from home period, you might VPN into your workplace. We could VPN into our student record stuff. We can have that available. It has to be encrypted. Next generation firewall firewalls are devices that filter access into a network, like a company network, in or out. So next generation firewalls can do things like open up each packet and look at it, look at what URLs the people are going to and prevent them from going to dangerous malware sites, things of that nature. Network access control is a means of, I'll give them an example. Suppose you bring a laptop to school and your laptop has a virus on it and you don't realize it or know about it yet. What a network admission control system can do is when you plug in that laptop into the system, before he allows you any access to the network, he's going to scan your machine, the network is. And if he finds some malware in your machine, he will not allow you to be connected to the internal company network. He may give you sort of a pass-through to the outside internet where you can not harm, the inside Tarrant County College network. So there's many products that have these type of things. So if an employee unwittingly opens up an email and infects some sort of virus on his computer, network admission control will partition his computer away. So if somebody that works at Tarrant County College, like a faculty or staff, open up a malware and it affects their computer, it immediately disconnects them from the inside network, and the IT security department knows about it right away. They can try to fix it. So how can we protect endpoints? So an endpoint is an in system, not an intermediate system. So laptops, desktop computers, server machines, IP telephones, as well as the employee-owned devices, tablets, or laptop computers that you bring in. So these can easily pick up stuff because we can't have control over your laptop. It's not our laptop. So endpoints can use something like Zone Alarm or other types of software that you install on your, say, a laptop PC that will look for any type of program with bad performance, like a virus that's going to try to infect your system. Hang on, I got somebody signing in. So he says in this last point that a desktop PC or a laptop PC, some type of endpoint, you should use some sort of network admission control on the company network. AMP software is what TCC is currently using for antivirus software. It's similar to Norton or McAfee. An email security appliance and web security appliance to prevent bad emails with poisonous links in them or bad web pages to infect your company networks. I like to call security like layers of an onion. Some exploit may get through one layer, but if you're deploying multiple layers, maybe the next layer will stop it. Okay, so Cisco has an email security appliance that will simple mail transfer protocol. It's a protocol that transmits email from the sender to the receiver. So the Cisco email security appliance, warning, War Robinson, this is some Cisco marketing fluff. So it's going to look for emails that have embedded links in them that are they're not legitimate. They're trying to trick you into clicking on them, so you'll infect your computer with their ransomware secret code, and eventually they're going to take over the company. And Cisco's not the only company that makes these type of things that you can put on your email. And Cisco also has a bit of more marketing fluff about their web-based software that'll also look for bad websites. Stand by 1, 2, 3, 4, 5, 6. Okay, previously we've done this technique here. Let's see, if I wiggle my mouse here, does it show up? Oh, it doesn't show up at all for you guys. Okay, in that little smaller black graphic on the right-hand side in the upper half of the page, he's talking about the way that we normally would do a password, like line console 0 password Cisco login. In this case, line VTY 04. He's going through the telnet ports. He's put a password on and the word login. Everybody uses the same password. Maybe you have an enterprise where you want to give individual people's individual account names and passwords, like we normally do with our servers. Everybody doesn't use the same name and password. Everybody has their own secret name, their own name and secret password. So in the second bigger black print from R1, you can see he's gone into the example here where he's created a individual username, admin, and he has his own particular password. So that way we can have multiple users log in. We can create these databases of names and users on each individual device. That's cumbersome if you have more than a few. Or you can use another device that's similar in function to the Microsoft Active Directory domain services, where the single names and passwords are stored on an authentication server like AAA or Radius or TakeAx, and these things check the passwords for you. Now he mentions about the simple method of remote access. That's what we do in the labs. We just go console Cisco, BTY Cisco, enable secret word class. In a real production network, that would be weak security. You probably wouldn't want to use just Telnet. You probably want to use something like Secure Shell, which is like Telnet, but it encrypts everything. Telnet doesn't encrypt anything. You can run Wireshark. You can see everything they're doing, including their name and password. So we can use Secure Shell and use individual passwords. That's much more secure. The problem is it's a local database of users and passwords on each device. And so we've got to configure it individually on each device. So if there's more than a few devices, we would have some sort of centralized place where the name and password is kept. So AAA, authentication, authorization, and accounting. These are one of the three tenets of security. And we're going to look at each one of these individually. So if I was going to give you security in 5 minutes, I'd say confidentiality, integrity, availability, and then AAA for logging people into the network and checking what they're doing and putting them in log files. So let's look at this very first thing, authentication. How can I authenticate if you're, who are you? Are you really you? You would know your password if you were you. So I can use names and passwords that are stored on the top part, local AAA authentication. I can use them on the network device itself. That's for small networks. If there's more than just a few devices, it's much too cumbersome to have to go and change passwords when people leave the company or new people are added. And we don't do this with individual desktop computers. We don't go to each individual 24 computers in the classroom when you change your password. You don't have to change your password on 24 of them. You change your password on one computer, and it's saved on the Microsoft Active Directory domain server computer. And then whenever you go to another computer, he also checks that same Active Directory database, and it's your changed password just one time. In server-based AAA is like Microsoft Active Directory. There's a central server that stores everyone's names and passwords, and you only have to change it on that device once. So if someone leaves the company, you can disable their account once. If you get a new employee, you can create this account once. And this is where all the usernames and passwords for all users are stored in this one device. And then all the routers and servers can check with that device when people try to log into that device and say, is that the correct name and password? Same exact thing when you log onto your desktop PC in the lab. Your desktop PC running Windows 10 checks with a Windows Server computer, the Active Directory server computer, and gives him back and says, yes, that's the correct name and password. And you're allowed to access your individual computer. So authorization is once you authenticate with your correct name and password, and I give you access to the system, authorization is to what level of access do you get to everything in the company or school network. If you're obviously, if you're the payroll clerk, you get access to the payroll files. I can't go into the payroll files and add zeros to my payroll check. I'm not authorized to do that. Students can't go in and change other students' grades. Well, what if you could change? Yeah, what if I could change my own grades to all A's and issue myself $1,000 tuition refund checks? No, you're not authorized to do that. Only certain employees are authorized to do things like this. So authorization decrees what you get to once you're on the network. So the dean's got great, has a lot of stuff he can get you on the network. But individual students have very limited access to what they can do, or individual staff or faculty members. I can only go in and put in grades for my classes. I can't go in and put in grades for other people's classes, for example. Okay, accounting is once you've authenticated on the network with the proper password, and some IT guy or supervisor has deemed what you get access to, that's authorization. And after that is log files accounting. We're going to keep log files on the system and try to keep the date and time on them so they're all in step with each other, in sync with each other. So that way, when something happens on the network, we need to check it out. We can go into the logging file. So that's accounting. We can see what time you logged in. We can see what time you logged out. You know, some people might log in late and stay late. You know, Patrick in accounting, he might need to stay over the weekend and do the end of the month report. And it would be normal, well, we could check the log files and see. But if I saw a log file and saw, oh, Patrick was on the server from 3 a.m. to 7 a.m. on Sunday morning, no, Patrick never comes in on Sunday morning, I would know someone's trying to break into the system. Okay, 802.1x authentication is what most of you guys, I think, are on cable internet service at home. Okay, I'm the holdout here. I'm the lone holdout. I was in the old DSL system from the phone company. I'm in the new DSL system now. The new DSL system uses 802.1x authentication, where my name and password is embedded into the little, you get from the phone company, you get one box, and it's a sort of like a combination cable modem and home router all in one box. Or in that case, it's like a combination DSL modem and home router all in one box. It's got the built-in Wi-Fi. Excellent Wi-Fi, by the way, on the one they gave me. And that's gives me the access to what I'm supposed to get from my particular account that I paid for. Okay, so 802.1x is a supplement, a client. That's a device like a desktop PC. He wants to log into the system. So he's going to put in his name and password under the hood for the user. The switch itself that he's plugged into, the workgroup switch, he's the authenticator. He's going to pass that traffic on to the authentication server, the server on the right, and he's the one that has the one single copy of your name and password. And then he'll pass it back and allow the workstation to go get access on the network. Okay, layer 2 security. Here's a reminder about what layer 2 is. Layer 2, the data link layer, that's where Ethernet lives. So down the physical layer, Ethernet connects down to the physical layer, to the physical wires and cables connecting us to the rest of all the other devices. And then the upper layers are software layers. So that's a place where compromises often occur is at the Ethernet layer. They're going to send you, a ping of death or an Ethernet frame that's been specially crafted to try to break into the system. So our best defense against this is to do stuff with our access layer Ethernet switches that connect to our end users and maybe untrusted end users who bring in laptops or whatever. We need to have extra strong protection at that particular layer. So if I can get into your layer 2, I can get into all your upper layers and do stuff. I've compromised your corporate network, your enterprise network. So here are some things we can do at layer 2. We can do a MAC table attack. There's a MAC address table in all switches that keeps track of what MAC addresses are physically present at which ports. And if I can get into that table and mess up with it, or maybe just flood it with it, if I flood it with 100,000 spurious, bogus entries, he'll fill up and all of a sudden the switch will turn into a hub and everybody hears all traffic. That's what I wanted. I wanted to hear all traffic. I'm the malicious intruder guy. VLAN attacks. I can come in one VLAN and try to hop to another VLAN. DHCP. What if I send a bunch of fake DHCP attempts to your legitimate DHCP server and starve it, and then maybe try to go in and pretend to be my own DHCP server and get information from other people. Address resolution protocol is a protocol that you broadcast out a request to say, if you have this layer 3 IP address, tell me what your MAC address is. I know my MAC address. I need to learn your destination address so I can send you something. That's what typically causes the first ping to fail. It's doing the ARP to look up and correlate the layer 2 MAC address with the layer 3 IP address of that device you're trying to ping. Address spoofing attacks. We can change MAC addresses. We can change IP address attacks. Common defenses against this that ISPs do is filter all that 192.168 traffic from your inside private network. It is not allowed to exist on the internet. No one can pretend to be a 192.168 similar address to what you use at home and try to get into your router. It will not allow it. Now, we talked about spanning tree protocol, which was the one that allows us to have multiple redundant links. And if there's a broadcast storm, it will stop that in its tracks. It won't allow any loops to take place. So if I can mess with your spanning tree protocol, maybe I can bring you to your knees with a broadcast storm. Okay, there are some techniques for preventing this. What we're going to look at in great detail in the next chapter is port security. We're going to do things with our switch ports on our access layer Cisco switches to make it much more difficult for people to break into the system. Now, what about that fake DHCP guy who's trying to give out fake DHCP addresses and pretend to be your default gateway just so he can snoop on everything that you're sending while he relays your traffic? We can prevent that with DHCP snooping. We can clean up our ARP problems with dynamic Arp Inspection, and we can prevent with IP source guard. We can clamp down on people that try to use rogue, unauthorized MAC and IP address to try to break into the system. Now, in a later course, it talks about at the bottom line using access control lists. Okay, what we're going to talk about today is data link layer Ethernet security, switch port security on switches. In the later course that we come back after, starting just before Halloween, when we have our second 8-week course, our fourth course, we're going to look at access control lists, which is where we can do security on layer 3, like IP addresses. So for example, in a school environment, we might say the kindergartners are on one subnet, they don't get to go to the internet. The juniors and seniors, they're on another subnet, they should be able to get to the internet. We can do things like that with access control lists. Okay, let's look at our MAC address table. He's done a show command here on the MAC address table, and we can see that there are 4 ports, and they each have individual unique IP addresses. So this is what the switch normally builds up so that when he receives any traffic for any one of these 4 ports, he can just ship it straight out privately to that individual port because it's in the MAC address table. If someone sent something to the switch and there was no corresponding entry in the MAC address table, well, he has to flood it like a broadcast. So, okay, can you tell who the bad guy is? Oh, they have him properly labeled here. He's a threat actor. Okay, this is like the spy versus spy guys. This is the black one. So this one is the one that's going to run some sort of attack. This MAC OF attack is an attack that fills up the MAC address table on that switch at number 2. And once this MAC address table is full, he turns back into a hub. He has to flood all data everywhere because we have disabled his MAC address table by filling it up with bogus garbage. Now the bad guy from the red computer is able to capture all traffic for all users, not just the private. Normally you won't hear other people's traffic because that's the efficiencies of a switch. Everybody doesn't hear everybody else's traffic. You get a private point-to-point connection. That's having a regular phone line instead of a party line. He turned it back into a party line. So what we can do is use port security. What we can do is only specify a certain number of MAC addresses to be learned on the port. We're going to look at that in the next chapter, next module. We can say, maybe I'll set the limit to 4 MAC addresses per port. That way, if somebody gets a new computer, they plug the new one in, it'll still work. But if someone tries this MAC OF attack, he'll only allow them to get 4 bogus addresses and it'll stop. Okay, no, I'm not going to show the video. We're going to talk about it. Okay, you get to watch the videos in chapters 12 and 13 on Wi-Fi. Okay, VLAN hopping attacks. Okay, a attacker brings a switch that he bought off eBay and plugs it in. He works in the tech support department, and he programs this switch so that switches, can trunk from device to device. And he goes and forms an unauthorized trunk. It'll do that 1Q tagging to the workgroup switch because someone forgot to say no switch port non-negotiate. Do not participate in this, dynamic trunking protocol thing. So no one programmed that port in the switch to not ignore that. And the guy's able to get a full trunking connection, which means he has access to all VLANs. He can see everything on all VLANs. Oh, I can't filter traffic by workgroups now. All right, so that's why I don't like dynamic trunking protocol, and I prefer to do the explicit command switchport mode trunk or switchport mode access with the insurance of switchport no negotiate to telling him not to listen for any stuff, unauthorized stuff like that. Okay, a double tagging attack is where I take a frame and frame it again. This is like the encapsulation of the envelopes thing I did in the fundamentals class. You put one envelope in one envelope, you put that second envelope in another envelope. So this way is a way of defeating the way of getting through to the switch where we might have, where we're filtering this stuff. So what we can do to mitigate, when we say mitigate, that means reduce the threat of. Automobile insurance is a mitigation against financial loss on your car. If you hit somebody, if somebody hits you, you won't have to pay the out-of-pocket costs. You'll be mitigated. You'll be made whole by when someone else pays you. The insurance carrier pays you for the cost, so you don't have to pay it. So in VLAN attack mitigation, we want to reduce these threats. So disable the trunking on all access ports. Yeah, don't use that VTP on. Disable auto trunking. No negotiation. No. Switch port, no negotiate. Make sure the native VLAN is only used for trunking links. Because if he can get access to a native VLAN, he can double tag. All right. So let's not have any of that. Okay, remember DHCP, DORA, discover, offer, request, acknowledge. So DHCP messages are sent in the form of a broadcast, or if you have DHCP relay, you know, your friendly neighborhood default gateway router is going to change that broadcast to a unicast so it can survive its trip to the real authorized DHCP server. So what's going to happen here is in a DHCP attack, one thing I do is try to lease. This is like when we tried to fill the MAC address table on the switch ports. I'm going to try to fool the DHCP legitimate server into giving me all its available addresses so that no one else can get addresses. And then I can proceed to be spoofing. I'm a rogue DHCP server. I want to give addresses to people that have a wrong default gateway where I can be the man in the middle and see everything. Give the wrong DNS server so that they go to bad websites that install malicious software. Give it a wrong IP address. So we need to defend against these sort of things. And Cisco does have a technique for that. Okay, address resolution protocol is the normal thing is the first one. A host machine in its ARP table, if we type ARP-A on a Windows workstation, there are no entries on the table because they normally fade out after 3 minutes. So you type ping 192.168.10.11. You want to ping your PCB. It's been more than 3 minutes since you pinged them last time. So the ARP table is empty. And the host sends out a broadcast message essentially saying, calling all stations, I am a broadcast. If your IP address happens to be 192.168.10.11, I'm trying to ping you. Would you kindly send me back your MAC address so I can place this ping echo request reply into an Ethernet frame and address it to you so you will get it? I don't have to stop shouting so loudly with all these broadcasts, just bothering everybody else in the entire network. And then the querying the machine that actually has that IP address will respond with an entry. It'll respond with the reply and says, here's my MAC address, and the broadcast stops. There's also something called a gratuitous ARP. That's not normally used in modern networks. It's too dangerous. So we're not going to use that because an attacker could use that to spoof a MAC address. And the switch would update his MAC address with spoofed false information that's going to allow these guys to break into the system. Now, IP version 6 is slightly different. In IP version 4, we send out a broadcast message, ARP message saying, well, if you have this IP address, please tell me what your MAC address is. Well, IP version 6 has the same problem. He needs to be able to say to everybody else, if you have this particular IP version 6 address, what's your layer 2 MAC address? Because I need to send something. I need to send this IPv6 packet to you in an Ethernet frame. Instead of I need to send this IP version 4 packet to you in an Ethernet frame. So they wanted people to feel good about IP version 6. So it does the same thing a broadcast would do, but we're just not going to call it a broadcast anymore. We're going to call it an anycast. So IPv6 sends out this neighbor discovery protocol, and he tries to find out what all the MAC addresses are of his neighbors. And he learns those and he puts them in a table. Okay, address spoofing attacks. IP layer 3 addresses, like IP version 4 or IP version 6 addresses. I want to spoof your IP version 4 address. I'm a bad guy. I want to take over a another device on your network. We'll just use some random address. So if it's inside that subnet within the company, that's difficult to mitigate. If it's from the outside world, we can do things with our routers and access control lists to try to fix that stuff. Okay, the second point, MAC address spoofing. I want to, now normally your machine's going to boot up and he's going to use that hardware 48-bit address of the MAC address, media access control, that's a physical value in the ROM chip of your network adapter. He's going to use that value. Now the hackers tell me that they can go into the Windows registry and change their MAC address to something else. I can think of no good reason why you would ever want to change your MAC address. The hardware one you got is perfectly valid for all valid, legitimate stuff. The only reason people want to change their MAC addresses is the same reason that kids carry fake IDs. They want to pretend to be somebody else. So if this occurs, we can pull the switch into doing stuff it's not supposed to be doing. Now, there's nothing in layer 2 that we can do with the switch to prevent against this, but we can use IP source guard, which is a technique we can use on the routers. So spanning tree protocol, what if normally spanning tree protocol will elect the root bridge, and it's supposed to be the most powerful switch in the whole company because it's having to run all this extra code for checking and stopping loops. So if I can go in and pretend to be a lower MAC address, well, the lowest MAC address becomes a root bridge, right? Then I can take over the system and try to mess up the spanning tree stuff. Well, there's a prevention attack here called Bridge Protocol Data Unit Guard on the access ports. And what that does is access ports that go to neighboring PCs, they'll never go to another switch. Well, we're going to program those ports and say, if you ever hear a Bridge Protocol Data Unit from a supposed host machine, something's gone wrong here. He bought a switch and he plugged it in, and he's not supposed to do that. And it'll partition the switch off where you can't create havoc in the company. Layers of an onion. We're going to do much stuff that we can. Now, I talked about Cisco Discovery Protocol. It is a great technique for finding out what your directly attached network devices are, routers and switches, on by default on all Cisco devices. And we can also use these to help configure devices, troubleshoot devices, find out what version of iOS they are. It's on by default. It gives away the farm. It gives away a lot of information. Within the company, this is great. We probably need it in our company because CDP is used by the Cisco phones to figure out what extension they're supposed to be. We generally don't want it to be to the outside world or to an untrusted network. Now, it can be turned off globally with no CDP run, but what we normally would do is maybe we have a serial port that goes to our ISP. We're going to go to that serial port interface 0000, be in the global configuration mode and say no CDP enable on that individual port, and it'll be disabled there, but it'll still run on our inside ports, our Ethernet ports, so the phones will work. The equivalent of Cisco Discovery Protocol in the open world, open standard world, is Link Layer Discovery Protocol. It's kind of like CDP, but it works with other devices. CDP is proprietary to only Cisco devices. LLDP is open standard, everybody supports it. It's turned off by default on Cisco switches and routers, but you can turn it on and use it if you want to do that. And it'll actually talk with your desktop Windows PC and see that it's a neighbor. So it can be turned on or off similarly by either globally or on a per interface mode. Oh, time to go to the next one. Hang loose, hang loose. Okay, now we're going to talk and get to the nuts and bolts here of port security and some iOS commands for implementing some of these security features. Now, we have already done this in some of our labs. It's considered good practice that ports on a switch that are not in use should be shut down. And the second thing we normally did was we put them in a garbage VLAN. So instead of typing individual commands for all 26 ports on our switch, we can use the interface range command and do it in one fell swoop on a bunch of ports at the same time. So I can type the command interface range fast Ethernet 0/1 through 24 and turn them all off at the same time. Okay, so this is a great defense against port security. We're going to limit the number of MAC addresses that he will listen to on a port and put into the MAC address table. So I can either manually configure the MAC addresses. Oh, we ain't gonna do that. That's too much trouble to write down all those addresses. You're gonna type in too many mistakes. We're gonna do the second thing. We're gonna permit the switch to dynamically learn the MAC addresses. That's what they do anyway. Switches dynamically learn MAC addresses. We're gonna let them learn the legitimate addresses and memorize them forever, so that unauthorized MAC addresses can't come in. So look at that last point. Let's limit the number of permitted MAC addresses to 1. So that way, just the legitimate device that was plugged in, the dean's computer, for example, on port 6, no one else can unplug, go into the wiring closet, social engineer their way into the wiring closet, unplug the dean's computer. He'll never notice he's off at a meeting. And plug their device in and get access to the network. They'll have the wrong MAC address. So they will not get access to the network. Now, one that is a little bit too much in many applications, for example, our VMs that we run, our VMware virtual workstation VMs, they create a couple of additional MAC addresses. So we have to, if the lab says put it on 1, you might need to increase it to 2. So we're going to use command switchport port security on the interface. In the example of this print, he's gone to interface port F0/1, and it's gone to the config-if, and he's given the command switchport port-security, and the command rejected it because it had not yet been explicitly set to an access port, because it was dynamically wanting to listen to, oh, DTP, should I listen to and become dynamic desirable, dynamic auto? No, he disabled that. He said switchport mode access, unconditional access mode, never be a trunk, and then say switchport port security, and he accepted the command. Now, this is the default setting. The violation mode is shut down, and the maximum number of MAC addresses is 1. This is the default. So as soon as I plug the dean's computer into port 6, he'll learn the dean's legitimate computer that's in the dean's office suite, and he'll add that to his maximum. That's the one address that he gets by default. Now, what happens if someone gets their way, social engineers their way into the wiring closet, unplugs the dean's wire in the switching closet from port 6 and plugs in their unauthorized device? A security violation will occur, and the port will, it will not shut down. Some of the literature implies that it's in the shutdown state. It's in the error disabled state. It's in a state where it will not allow traffic to pass, but it's still listening to what's going on, but it will not allow any traffic to pass. When you shut a port down, he stops listening. He has no idea what's going on. So this is an error disabled state that must be reset by an administrator when the problem has been corrected. So here's some ways we can modify this. How long is this port security going to last? Aging, 5 minutes or something. We can set it to whatever we want to. We can put in a MAC address. We can type in manually a MAC address that we want to. Now, that's not recommended. That's too prone for mistakes. So if I said, hey, Dorian, would you go around to all the rooms in the building today and write down all the MAC addresses and key them into the switches for me? And we have 12 switches. That would be too much of a chance of errors being committed. It takes too long. Instead, we're going to use a method the switch is memorizing MAC addresses anyway. We're going to use a sticky method where he just memorizes those addresses and keeps on even if 5 minutes pass or even if the switch reboots. Maximum number was 1. Well, we can change that. In our labs, we should probably use 2 or whatever he tells you. If he says 1 in the lab, boost it up to 2, because otherwise the real machine's MAC address and the workstation, VMware workstations, PCA MAC address might cause that problem to occur. Now, violation mode. What happens when there's a violation? By default, you're error disabled. We're going to look at some options for this. Okay, so by default, switchport port security maximum is 1. 1 MAC address only. You could raise it to thousands if you want to. But that's not good security. We'll put it to a reasonable value like 2 or 3 or 4 in a real production environment. What if it goes to another room, a conference room where there's a switch, a little Office Depot switch, and there's 5 ports in there? You'd have to raise it to 5. So administrators decide these things. Okay, here's our 3 methods of learning MAC addresses that we were going to apply switchport security to. Okay, the first one, manually configured. Oh, Dorian got so upset when I told him that he's going to log off of the machine here because he doesn't want to have to run around 400 different machines in the SBUS building and write down all their MAC addresses. That would take days. So we could do this if we wanted to. We could type switchport port security MAC address and type in that 12 hexadecimal digit representation of the 48-bit MAC address. Yeah, we don't want to do that. Okay, number 2, dynamically learned. Well, switches learn MAC addresses anyway. Let's just let him memorize that MAC address that he learned when that workstation was turned on in the morning, when the dean flipped on his PC in the morning. The problem with that is if the switch is rebooted, there's a power loss, or it had a crash and it rebooted, he forgets the MAC address. So what I really like is number 3, sticky. We're going to use number 2 and have them dynamically learn it and save them in the NVRAM. Switchport port security MAC address sticky. Make that address sticky and make it be saved in the NVRAM, the non-volatile memory, in the computer, in the device router or switch, so if that switch is rebooted, he doesn't have to learn it again. Because a bad guy could get in the closet, remove the power, and plug the power back in, and he forgets everything. So in this particular example, at the top of the print, he said switchport mode access, switchport port security, and a maximum of 4 addresses allowed. And he specified an individual MAC address. He says an example of adding an address by hand. And then he says switchport port security MAC address sticky, and it will remember all these addresses. Then we can do show port security interface and show port security address commands to verify the configuration by looking at the output of the show commands. Okay, support security aging. Are we going to delete it after a certain amount of time? So we can type port security aging and then define whether it's inactivity on the device, on the port number, or absolute time. We can choose either that. So if we do inactivity 3 weeks, then someone that goes on vacation for more than 3 weeks, they would delete it. Okay, in this example, he has set the port security aging time to 10 minutes of inactivity. And after 10 minutes of inactivity, it's going to erase the value. And then we can do short port security and check the status on this. Okay, here are our 3 ways we had our 3 ways of remembering MAC addresses. Now here are our 3 ways of what happens when a security violation occurs. I don't like this chart. It says shutdown. That's not correct. It's error disabled. The mode is not shut down. The light does not go out. What happens is the text is correct. The port transitions to the error disabled state immediately and sends out a syslog message if it's been configured as such. Increments the violation counter. The way to reset this is you have to go to the port. You have to log in as administrator, switch administrator, and go to the interface port. And let's say it was a Dean's port FA0/6. You have to shut down and then no shutdown. Well, if the left-hand column of the chart was shut down, I wouldn't have to type shutdown. It wouldn't be shut down yet. It's in the error disabled state. It's mostly disabled, but not completely. You have to completely shut it down and then do a no shutdown command to reset it. I'm going to compare this to, you ever had a circuit breaker flip and the light went out? And you go outside and you're trying to figure out which circuit breaker is the one that blew. And if you look at them very carefully, you'll see that one circuit breaker that actually activated, it didn't flip over to the off side. It moved about 1/16 of an inch. How do you fix the problem? You must take the circuit breaker and turn it completely off. And then you must take the circuit breaker and turn it back completely on again to turn that circuit breaker back on. The same thing we have to do with the switch port on the switch. We have to do the shutdown command and completely turn it off. And then we have to tap the no shutdown command and completely turn it back on again. And then it'll finally start working. Okay, so that's the default mode as it goes to the error disabled. The restrict mode is he's not gonna go into the error disabled mode. He's going to just drop the packets. And then the last mode, protect, that's the least invasive of all. He's going to drop packets with unknown MAC source addresses. No syslog messages sent. Yeah, so we don't care about anything, we'll do this. So the most secure method is going to be the first mode. error disabled state, what he calls shutdown, the default state. Yeah, if a bad MAC address is encountered on that port, I want to know about it. The line's going to go dead. The dean's going to call and complain. And I'm going to go in the wiring closet and discover someone has plugged in a bug on the port 6 of his device and then unplug the dean's computer. I want to know what's going on. So in this case, he changed it to the mode restrict, and show port security interface shows it's in the restricted mode. Okay, when the port is, he says shut down again, that's not correct. When a port is error disabled and it's placed in the error disabled state, it is not shut down. We have to type shutdown and then no shutdown to reset it. It's a sort of a ghostly almost shutdown. And I'm going to call it its correct name, the error disabled state. No traffic is sent or received on that port. So we might see this on the iOS screen if we were looking at the switch at the example that the violation occurred. In this case, he's detected a problem with port number 18. It's been put in the error disabled state because the MAC address that's listed on the 4th line there was not an authorized MAC address on port 18. So he changed state to down, not administratively down. You notice it always says when you type shutdown, it says administratively down. It is not, you know, it's like that movie, The Princess Bride. He's not completely dead. He's only mostly dead. Okay, and they were able to revive him. So this state, he's almost mostly dead, but he's not completely dead yet. But you still have to type shutdown and kill him completely, and then type no shutdown to bring it back alive again, to reset that port, just like that circuit breaker. So show interface shows in this case that the port status is in error disabled. It's down and down. It is not administratively down. If I type shutdown, it's down and down, administratively down. It's not error disabled. The true state is error disabled, not shut down, not administratively shut down. So to fix this, I'll type shutdown to completely purge it, and then type no shutdown to completely activate it again. This is normal procedure for recovering from an error disabled. So we can check this with show port security, and it'll show us the status of all the ports, how many violations occurred, etc. on each one. And then show port security interface can look at the individual interface. We saw this command earlier. In this case, it's set to the disable the default configuration. If we want to make sure that it's sticky, remember we said port security MAC address sticky will make him remember it even if the device has to reboot. Well, it's added a line to the iOS listing with that sticky address that he learned. All we got to do is occasionally do a copy run start command and save that running configuration to the startup configuration in NVRAM, and the switch is protected. If it's ever crashes and reboots, when they crash, when these switches and routers crash, they automatically reboot. Kind of like Windows, he crashes, he sort of automatically reboots. Or if there's a power failure and he turns off and on again, it would reboot. So he's using the command show port-security address to see which addresses have been, what state each one is in. So one's in secure dynamic, port 18's in secure dynamic, where he remembers the address, but he doesn't put it in the running config. And port 19 is in secure sticky, where he memorizes the address and he puts it in the running configuration so it can be saved with copy run start and be retained if there's a power failure or a crash. Okay, VLAN hoppings. We talked about that in the last one. I want to spoof a desktop dynamic trunking protocol message and convince my access port to be a trunking port so that I get access to all the networks, not just the one I was supposed to be getting access to. So I can introduce a rogue switch. I can go get a cheap switch from eBay and enable trunking on that port. And if they've been careless, the system administrator doesn't understand DTP and they left it on automatic, I can trunk right up to that switch. And then the attacker, can get to all the other VLANs that switch has. Or use double tagging if they gave me a native port. They should never give me a native VLAN port. So let's disable DTP entirely. Switch port mode access disables it entirely. Take unused ports and put them in an unused VLAN. In this case, he's taken the port ranges of 21 through 24, and he's put them into a native VLAN, and he's going to, that's the garbage can VLAN. Put them in an unused VLAN. Step 3, if I want to be a trunking port, I'm going to use the command switchport more trunk. If I don't want dynamic trunking protocol on trunking ports, I can use a switchport no negotiate command. And then the last step 5 was set that trunking native number to something other than VLAN 1, the default. In our labs, we have generally done it on VLAN 999 or VLAN 1000. Okay, now we talked about a little bit in the last module about the problems of being able to attack the DHCP server by using a similar technique I would attack the switch with. Fill up his MAC address table on the switch. Floods all data now, I hear all data. DHCP server, I'm gonna fill up the DHCP server's pool with a bunch of fake addresses. And then I'm gonna act as a rogue DHCP server to do this. So we can fix this with a Cisco feature called DHCP Snooping. What we do is, he's going to give us he has a configuration example, good. All right, it's coming up soon. So what DHCP Snooping does is we're going to find which ports are untrusted ports. Access ports that go to employees' PCs are untrusted ports. We should never accept any DHCP traffic from them. Any broadcast traffic of a DHCP client saying, please, a result of traffic from a DHCP server giving addresses to people. Untrusted ports can only request DHCP server from a legitimate DHCP server itself. So devices that we control, like switches and routers and servers, we're going to trust those. Oh yeah, we have to trust the server. It's a Microsoft Windows 2018 server, and it's being the DHCP and the DNS server for the whole company. So explicitly trusted interfaces, trunking link server ports, we're going to configure them as trusted. All the other ports that go to desktop PCs, printers, fax machines, things like that, those are untrusted ports. We don't want anybody to program their desktop PC to be a DHCP server as a rogue server that's not authorized on the network and try to make it take over. Now, you guys that are going to go on and take Microsoft courses like ITNW 1454, configuring Microsoft servers, there's a Microsoft feature that when you set up your Microsoft server, which are commonly used in business today, to be the DHCP server and the DNS server for your small company enterprise, he has a feature that he will not allow a rogue DHCP server to come into the network. It has to be authorized by the Active Directory domain controller itself. So layers of an onion, if you're in a Microsoft network, configure that on your Microsoft server. Using Cisco devices, configure DHCP snooping on your Cisco devices. So the way to do this is we're going to turn on the DHCP function, IP DHCP snooping, global configuration on the device. On our ports that we trust, like trunking ports of the devices, other switches and routers, IP DHCP snooping trust. On untrusted devices, we can even limit the amount of DHCP attempts to try to be a rogue, untrusted, unauthorized DHCP server by saying IP DHCP snooping limit rate and reduce that command. And we can do this on a VLAN by VLAN basis or on all of them at the same time. Okay, so here's an example of, we have on the right-hand side, we have an authorized legitimate DHCP server, 10.10. And then we have switch 1, the access layer switch, connecting to the employee machine that's using this. So the first thing we're going to do is go to switch 1 and turn on the IP DHCP snooping function and go to port 1, which goes to the trusted server, and say, you can trust this port, or port F01, I know it goes to the server. Now, all the other ports that go out to our desktop PCs, ports 5 through 24, we're going to limit the rate of them to a very low amount to quench this in the bud. So no one can like run that program and try to do 100,000 DHCP requests all at once and overwhelm the DHCP server. And then finally, he's going to put it on the particular VLANs that we wanted to run on, the ones that are in use in the company. So iOS show command, show IP DHCP snooping, we can see the configuration that's been put up. If we're using another feature called dynamic Arp Inspection, DHCP snooping is also required by that. That's in another frame or so. Okay, Arp attacks. Arp is the function that synchronizes and memorizes the correlation between another machine's IP address and what its MAC address is, for about 3 to 5 minutes. So in an ARP attack, a malicious user, hacker type guy, can send out unsolicited ARP requests and try to, fill up their tables or reroute everything to a man-in-the-middle attack to one guy. So dynamic ARP inspection is Cisco's technique. We turn on DHCP first. We're probably going to do this on a network. We actually have real security aims, security policies, and this can help prevent our ARP attacks. So gratuitous, invalid ARPs, we shouldn't want that on a network anyway. Untrusted ports, we're going to intercept those. We're going to make sure that intercepted packets have a valid, this is what ARP does, it correlates and lines up your layer 3 valid IP address with the actual MAC address, not some fake address. So to implement this, we're going to, again, set up ports that go from switches, in this case, from a switch to a router. And all ports that go to users only have access to those wires in their cube or their office. Those are not trusted ports. Anybody can plug anything into one of those ports. So we don't trust those ports at all. So we're going to configure all those ports to be untrusted ports, limit the amount of traffic that can go back into our system. So as an example, he's given the command from the global configuration mode of S1. He's turned on IP DHCP Snooping, specified it for VLAN 10. And he's also given the command IP Arp Inspection at VLAN 10. And then on that individual port, an untrusted port, or in this case, a trusted port, IP DHCP Snooping Trust and IP Arp Inspection Trust. Yeah, it's going to a server or router. We can trust that. So this DI can check for destination or source MAC and IP addresses. So destination MAC address, what's the destination address that trapped host machine is trying to send the Ethernet frame to? Check the source MAC address against the sender MAC address and the ARP body. So it's got to match the real hardware. IP address, we don't want any kind of IP address. We don't want 0.0.0.0. That's like the wildcard that matches everything. We don't want any multicast. Host machines don't use those. We don't want the 255.255.255.255. So he'll check for all that. So we can type a number of ARP show commands here. IP ARP inspection, validate, and set this up to configure it, check for, validate all source address MAC addresses, validate all destination MAC addresses, validate all source and destination IP addresses. We can very carefully configure it selectively to what we want to do according to the security policies at the company that you're working at when you set this up. Okay, what about spanning tree protocol? There was a feature that we mentioned in spanning tree protocol that normally an access port that goes to a desktop PC doesn't need to go through this 50-second delay because it's never going to connect to another switch. So we can use this configuration command at port fast so that when that user flips on their PC, it could be a laptop PC, boots up in 5 seconds. He can't wait 50 seconds. He's going to get an error message when he tries to log in. So what port fast is going to do is bring that port up almost instantly, about 1 second. Right through all those listening, learning, blocking, it's going to bring it to a forwarding state right away. And then that 5-second laptop will be able to log right into the network. Normally, those are end-user access ports we apply those to. Now, Bridge Protocol Data Unit Guard says, well, you configured me to go to an end-user device, not to another switch. And just in case you lied to me, I'm going to keep listening for Bridge Protocol data units on that port. And that means someone plugged a switch into it. And I'm going to immediately reverse what you did with the port fast. So this way, if somebody goes to eBay and buys a switch and hauls it into the cube in the tech support area and plugs that switch port his PC was plugged into, that port he was plugged into will immediately start hearing Bridge Protocol data units, and he knows that, oh, it was configured to port fast, but I must take corrective measures now. He's trying to hijack me into becoming a tracking port. So port fast disables this 50-second limit, goes into a real fast time. Now, if you try to do this on a switch to switch, could create a spanning tree loop. He warns you when you type spanning tree port fast. He warns you that it should only go on to single host machines, not bridges and switches and hubs. That could create a loop. So we can do port fast on a single interface port, like he's doing in the print. Or we can do it at the bottom of the screen print. He says spanning tree port fast default, all ports. So you can do it for the whole switch. Maybe it's a switch that goes on user machines. And you don't have to type it 26 times. Okay, we can use the command show running config and then that pipeline character, the up and down line, begin span, B, span works. It'll bring all the lines of the iOS so you don't have to press the space bar and go through 3 or 4 pages. Or you can type show spanning tree summary and see that information. Okay, if I do want to turn on bridge protocol data unit guard, BPDU guard, I will do access ports that I'm going to configure so that if someone plugs a switch into that port or some administrator accidentally plugs 2 switches together on a port that was supposed to go to end users, this will cause the, it'll go into an air disabled state because he started doing bridge protocol data units. So we can do it on an individual interface by interface basis or globally, just like we could do with port fast. Okay, hold on the line here. Oops, no, I don't want that, I want this. Okay, so I covered the 10 through 11 on switchport security, general network security. I'm asking you guys to view the Network Academy videos on chapter modules 12 and 13 to cover Wi-Fi. And we won't do a lab on Wi-Fi, but we will be doing a lab on Thursday on switchport security. That's going to be a lab 11.6.2. Here in person, face-to-face in SBUS 1125 when you guys report on Thursday. Let's see, I think I mentioned, I should mention again, a couple things, yeah. About half of you guys are pretty much caught up on your module test. There's 5 module tests and the final exam I'll turn on the last week. About half of you guys haven't taken the 1 test yet. Don't be overwhelmed. I have all those exams, 5 exams, activated pretty much all the time. If you ever have any problems with getting into a chapter assessment, module assessment, shoot me an email. I'll fix it as quick as I can. I haven't had any queries this semester. I think the test system is working okay. The other thing I wanted to mention was the open room. When you go to Cisco Collaborate and you see my classes, there's also a thing called a room where you can go into all the time. I generally leave it, it's on now as a matter of fact. You guys have full audio and video permissions in that particular room. So if you guys want to meet up, meet up in that room and talk to each other and study or something like that, you're welcome to use that as well. Okay, I think I've covered pretty much everything I need to. I'm going to hang loose again for a couple of minutes in case anyone has any chat questions or wants to shoot me an email or anything. And that's another one for the books, guys. Okay, see you guys Thursday.